Welcome, software architects. Today we are tackling two of the most critical concepts for building production-grade AI systems, managing multi-turn conversations and executing flawless multi-agent handoffs. Let's get started. Let's begin by defining multi-turn conversations. What are they? Simply put, they are ongoing dialogues where Claude builds upon previous context to solve complex problems. But here is the critical baseline you must understand. The Claude API is completely stateless. It remembers absolutely nothing between requests. Why does this matter? Because if you just send a follow-up question, Claude will have no idea what you are talking about. How do we solve this? As the architect, your application must maintain the conversation state. Every time a user speaks or Claude responds, you append that message to a local array, feeding the entire history back to the API on the next turn. Let's deep dive. In production, multi-turn doesn't just mean chatting with a user. It often means Claude talking back and forth with your backend tools entirely autonomously. Look at the sequence diagram illustrating stateless communication. The user sends the initial prompt to your application, which forwards the message array to the Claude API. The API returns an assistant message. In step 4, your application appends this response to its local history. When the user asks a follow-up in step 5, your app doesn't just send the new question. As shown in step 6, it sends the full, accumulated message history back to the API, ensuring Claude has the perfect context to answer the follow-up. Moving to slide 2, let's explore the multi-turn tool pattern. What is it? It is the ability to chain multiple tool calls together to solve a single request. The basics are fascinating. If a user asks, "What day is 103 days from today?" Claude cannot answer natively. It first requests a tool to get the current date. Once it has that, it requests a second tool to add 103 days. Why is this powerful? Because it replaces rigid, hard-coded scripts with dynamic, AI-driven routing. How does this work under the hood? Claude outputs a tool use block, your backend executes the Python function, and you send back a tool result block. Claude evaluates that result and immediately triggers the next tool. The deep dive here is strict state mapping. Your tool result must include the exact tool use ID Claude provided, or the entire chain will fail. This state diagram maps out a multi-turn tool chain without any user intervention. It starts with a user prompt hitting the Claude API. Claude needs the date, so it transitions to execute tool 1. We feed the result back, and Claude stays in the loop, transitioning to execute tool 2 to add the days. Only after all necessary data is gathered does the API transition to generating the final response and ending the turn. To make multi-turn tool use work, we must build an agentic loop. What is this? It's the physical code, typically a while loop, that manages the back-and-forth communication. Why is loop control so critical? Because a major exam anti-pattern is parsing natural language to end your loop. If you write code checking if Claude says task complete, your system will inevitably break. How do we do it right? Look at the sample code. We create a while-true loop that exclusively checks the deterministic stop reason field. If the reason is not tool use, we break the loop and return the final answer. If it is tool use, we execute the tools, append the results, and loop again. A crucial deep dive, you must append Claude's tool use block before appending your tool result block, preserving the exact conversational sequence. Here we visualize the code's control flow. The message goes to the API, and we hit the vital decision node, check stop reason. The green path loops back around. If tool use, extract arguments, run the local tool, append the result, and fire the API request again. The loop exits safely on end turn. Notice the red dashed line. Never parse natural language processing output for words like done to control your application state. Eventually, multi-turn conversations with a single agent hit a scaling wall. This is where multi-agent handoffs become essential. What is this? It's transitioning from a single monolithic agent to a hub-and-spoke architecture. Why do we need this? Because if you give one agent 18 different tools, its selection accuracy degrades massively. It gets confused between overlapping tools. The basics involve a coordinator, acting as the brain. It analyzes a complex request and performs a handoff, routing subtasks to specialized subagents. For example, routing a billing issue to a finance subagent that only has 4 finance tools. Let's deep dive into the architecture. The coordinator is the absolute source of truth. Subagents never talk directly to one another. The coordinator hands off the task, waits for the result, and then decides what to do next, maintaining total control over the workflow. This graph illustrates the hub-and-spoke handoff model. The user request hits the coordinator agent in the center. Based on the request, the coordinator performs explicit handoffs to the billing, dev, or research subagents. Crucially, look at the arrows. There are no lateral connections between the subagents. They execute their narrow tasks in isolation and hand their structured results back up to the coordinator, which then performs the final synthesis. How does the coordinator actually execute the handoff in code? It uses the task tool. What is this? It is a built-in mechanism in the Claude Agent SDK used specifically for spawning subagents. How do you enable it? The coordinator's allowed tools array must explicitly include task. Now, we must discuss the absolute golden rule of handoffs, context isolation. When a subagent spawns, it starts with a blank slate. It does not inherit the coordinator's memory. Why? Because passing a 50-turn conversation history to a subagent wastes thousands of tokens and pollutes its focus. The deep dive here is critical for your architecture. Look at the sample code. When handing off via the task tool, the coordinator must explicitly draft a targeted prompt and extract only the relevant context. Never pass the full global history during a handoff. This visual enforces the rule of context isolation during a handoff. On the left, we have the massive coordinator full history. The red line marked anti-pattern shows the mistake of dumping this entire history directly into the subagent. Instead, follow the green path. The coordinator intelligently extracts only the necessary variables to form a targeted payload. This lightweight payload is handed off via the task tool, ensuring the subagent operates with perfect, unpolluted focus. When a subagent completes its work, how does it hand the result back? We must use structured handoff protocols. What does this mean? It means returning structured data, not verbose conversational text. Why? Because the coordinator has a limited context budget. If 3 subagents return massive essays, the coordinator will suffer from context degradation. How we solve this is by instructing the subagent to return structured formats, like a case facts markdown table containing exact names, dates, and order numbers. Let's dive deep into error handoffs. If a subagent hits a database timeout, it must never silently return an empty array. Doing so tricks the coordinator into thinking no data exists. Instead, the subagent must hand off a structured error, clearly distinguishing an access failure from a genuinely empty result, allowing the coordinator to decide if it should retry or escalate. This flowchart maps the handoff protocol from the subagent back to the coordinator. Upon execution, if successful, the subagent returns structured case facts directly to synthesis. If an error occurs, it categorizes it. A database timeout returns an access failure with a retryable flag. A valid search with no hits returns an empty result with the error flag set to false. This structured metadata ensures the coordinator knows exactly how to handle the handoff. Let's bring this all together with a highly impactful real-world use case, an advanced customer support triage system. A customer logs in with a complex issue, their product is broken, and they were double charged. Step 1 relies on multi-turn conversations. Our coordinator chats dynamically with the user to extract the order ID and photo evidence. In Step 2, the coordinator analyzes the context and decomposes the problem. Step 3 is where the magic happens. The coordinator executes parallel multi-agent handoffs. It passes the photo to a tech subagent equipped with vision tools and simultaneously hands off the order ID to a billing subagent equipped with finance tools. Finally, in Step 4, the subagents return their structured findings. The coordinator synthesizes this data, resolving the ticket instantly. Mastering these orchestrations is exactly what the certification demands. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. In our final diagram, we visualize the end-to-end support triage architecture. The user's complex request hits the coordinator, which uses a multi-turn loop to gather missing data. It then initiates a parallel handoff, routing the photo payload to the tech subagent and the order ID payload to the billing subagent. Operating in isolated contexts, they execute their specific tools and return structured verification. The coordinator synthesizes these handoffs into a flawless, unified resolution for the customer.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.